already know about regular magnets. They have opposite poles that attract, similar poles that repel, and they can even attract other metal objects that don't attract each other, like these paper clips. You can also take a compass, which is itself a small magnet, and move it around near another magnet, and the needle will point in the direction of the magnetic field. So how does a coil of wire manage to behave the same way? It turns out that moving electrical charge, or current, creates a magnetic field. Watch what happens when I connect this piece of wire to a battery. It makes the compass needle move just like a magnet did, so we know the wire must be creating a magnetic field. This magnetic field takes a circular shape around the wire like this. However, the magnetic field around a single straight wire is very weak, not enough to pick up even one of these paper clips. You can make the magnetic field much stronger by wrapping the wire into a coil called a solenoid. This causes the fields around each individual turn of wire to add up to make a much stronger, more uniform magnetic field similar to that of a bar magnet like this. However, you'll see that this coil of wire is still too weak to pick up an individual paper clip. To make an electromagnet really strong, you need to add a ferromagnetic core like this iron bolt. Ferromagnetic materials have many smaller individual magnetic domains. Normally, these domains are aligned randomly and cancel each other out. However, in the presence of an external magnetic field, these domains align with each other and the external field, making the overall field much stronger. Watch what happens when I insert this iron bolt into the core of my electromagnet. Now it's finally strong enough to pick up a paperclip. Unlike a regular magnet, an electromagnet can be turned on and off by removing the flow of electrical current. If you reverse the direction of the electric current, you reverse the direction of the magnetic field. To change the strength of an electromagnet, you can change the number of turns in the coil, the length of the coil, the amount of current flowing through the coil, or the core material, all of which would make a great science project. Because they have very low resistance, the wires in electromagnets can get very hot, so you should always disconnect them when not in use. The paper electromagnet in this video was just for a demonstration, but you should not try this at home because the paper